Hello everyone, so in this video, let us talk about the first three problems from the latest Leetcode Biweekly contest 86. I'll also make a video on the fourth problem, so stay tuned on this channel. The first problem is find subarrays with equal sum. Okay, so you're given a zero index integer array nums. Determine that whether there exist two subarrays of length 2 with equal sum. Note that the two subarrays must begin at different indexes. That's the whole problem statement. In simple terms, you just have to find out that there exist two subarrays, or let's say contiguous elements, such that both of these subarrays have equal sum. Now, the simple way is just find out the subarray for all, and if you just find out the sum to be happening again, then the answer is true. How you can check it out? You have the array. You can just take two consecutive elements and simultaneously find out for all the subarrays. So let's say for these two elements, and so on. Let's say for this first two, second two, then third two, fourth two, and so on. So find it for all of them, and you can make a set or you can make a map, and whenever the same sum occurs, then it means that you have find out two subarrays of same sum. If you do not find, if you cannot find out any of them, then the answer is that false. So it is an O of n approach, just iterating over the whole array, and that's it. So what we have done is that I've iterated a map here, then iterated over, and because I'm matching I and I plus 1, so I should not be going till the very let's say 0 till n, because then for n plus 1 element will match, that is false. So I'm going from 0 till n minus 1, okay, less than n minus 1, and just find out the sum is nums of I and nums of I plus 1. And then if I just saw this sum again in the map, I just return true that I again see this sum, or else I just put this sum inside the map. And if after doing this whole iteration, if I don't see any sum to be occurred like a number of times, I just return. That's the whole solution for the first problem. Pretty much simple. Second problem. The second problem is strictly palindromic number. So an integer n is a strictly palindromic number if for every base p between 2 till n minus 2, if there exists a string such that if you represent that string in b base format, then it should be palindromic. So for all the bases, let's say from 2 till n minus 2, all those numbers should be palindromic. If they are, then the number is strictly palindrome, else the number is not palindrome. So it's very unlikely, and after the contest I also see that the answer is false for everything, okay. But what you can directly observe is that they want to try to say is that for every number, let's say for, if you just take it, let's say 100 only. So for, if you just represent 100 in base 2, 3, 4, 5 till 98, so base 98, if you represent 100 in all of those bases, then all the numbers should be palindrome. That is very, very, very unlikely. So answer is obviously false for this. You can just return false for this. But because it is very unlikely, what you can directly do is that you can just do in a very brute force way and just iterate over, and just for a checking purpose, okay, if you want to check it for small numbers, what you can directly do is that you can just iterate over and find out the value for, let's say, first 100 numbers, and you can obviously find out that all of them will be false, or actually everything is. But if you want to do this in a very brute force way, what you can do is that you just find out the number and find out its base representation in that particular base value, and then if it is not palindrome, just return false at that particular moment of time. Just don't iterate over and find it for all the 2 to n minus 1. That's our overall thing. So I'll just move on to the code part. It's very simple. What we have done is that we have taken the number, and for a particular number I just have to convert it to base, let's say b. Okay, so what I'll do is, and I have to convert it for all the base from 2 till n minus 2. So I've done a for loop here. Then for a particular number, let's say I've taken this number, so let us make a copy of it so that I have to convert that. So what is the best way to convert a number to its base value? What we just do is that we will divide that number, that particular number, by that particular base value, let's say b. Whatever is the modulus value of that, we'll take that and divide completely by I, and we will keep on completely dividing by I. So let's say for finding out base 2, what we'll do, we'll first divide it by 2, and whatever is the remainder, we'll take that and divide it by 2, and whatever is the remainder, divide by 2. Keep on doing that until we become 0. That's the whole scenario here as well. So we'll take this num and we just push back the remainder with I, that is the base, and just divide it by I, and keep on doing that, okay. And that's it. Now we have the particular number that is stored in this vector, that is num, and I just have to check that that should be palindrome. So what the best way is that I will take 2 pointers, one is the very left and one is the very right, just match them and just keep on coming to the close. And there are multiple ways to check whether the number is palindrome or not. So, or whether it's an array is palindrome or not. So we have taken 2 pointers, one at the left, that is the 0th element, 0 index, on the very right, that is the last index, and y left is less than right. If they both are same, then it is fine. If they're not same, let's say the left is not equal to right, if they're not same, then return false, that this is not a palindrome. So actually this is not a palindrome, so I just have to find out the number that has all the palindrome in all the bases. If we have found out a palindrome that is not base in this particular format, so not palindrome in this particular base, so it's not palindrome, like strictly palindrome, so just return false. Else if we find out the answer, then answer is true, so it will not hit that condition, it always be hitting this condition, the answer is always false. Okay, so that is the second problem. The third problem, maximum rows covered by a column. So you are given a zero indexed m cross n binary matrix, that is mat, and also an integer calls, now which denotes the number of columns you must choose. Okay, so you have a matrix as you can see, and a calls variable, that the number of columns you have to eventually choose in this matrix. So this is columns, let's say. Okay, now a row is covered by a set of columns if each cell in that row that has a value of 1 also lies on one of the columns that you have chosen, okay, from the chosen set. So in simple terms, a row is called covered if that particular row has at least one in a particular position that is also covered by the number of calls I have chosen. I'll tell you an example so that it will become more clear to you, and you just have to tell that what is a particular configuration of calls that I will choose such that I will get the maximum rows covered, and you just have to run the maximum number of rows that you can cover by choosing a particular configuration of calls columns. Okay, let's take an example of this only. So let's say that if I choose this and this, so I have, this is the matrix, and I can choose two columns. So let's say I'll choose the first and the last column. Now in this, if I choose this, can tell me how many rows are covered. The number of rows that will be covered is such that that particular row has a 1 on the column that I've chosen. So this row will be covered, no. This row will be covered, yes, because it has a 1 here. It is a 1 here as well, but I just need 1. Okay, so whether this row is covered, yes, because it has a 1 on this particular column. Whether this row is covered, yes, it has a 1 on this particular column. So 1, 2, 3. 3 rows are covered, and answer is 3. Got it? So if a particular row is covered when it has a 1 on the same column that I have chosen among the number of columns I have chosen. So you just have to find out that. Now how you can approach this problem, always move down to the constraints as well. So it's 12. So if you just find out, so for every column I have two options, either I will choose it or not choose it. Okay, so 2 to the power of 12, it's very small, so like only close to 5,000. So what's the simple approach here is that you will choose, like you will brute force over all the possible configurations, and among all the possible configurations of number of calls, you will find out the number of calls in which I have to choose, take this number of columns. Okay, and for among, if I take that number of columns, the matrix is also very small. Just check that how many rows are covered for a particular configuration, and just maximize the number of rows that will be covered, and just print out the answer. So it's a very simple brute force way, nothing much complicated here as well. So what we'll do is, first I have to first find out all the possible configurations, and when I want to find out the possible configurations, I have separate video as well. I'll tag them in the I button if you can check them out. But if you want to find out, let's take one small example. Let's say I have 5 positions. I have 5 columns, and what are different positions I can take? Let's say I have to take, let's say, 2 columns. So I can take this and this, okay, or I can take this and this. I can take this and this. There are different possible configurations. Okay, so what I can do is I can represent this as a, let's say, binary number, and I will just, let's say, if I switch this part on, let's say if I switch this as 1 and this as 1, which actually means that I have chosen this column and this column. Cool. So what we'll try to do is, like, this is a binary number, and the binary number can actually a number itself, which is represented as binary representation. So what we'll do is that we'll go from 0 to 2 to the power 5. Every number I'll take, which means that either I'll not take number or not take a number, and this will represent all the possible configurations in a 5-bit number. Okay, so this is 32. So from iterate over from 0 to 32, and this number will represent all the possible configuration. It has 1, 0, all of that. In all of those configurations, we'll choose how many numbers have 2-bit that are set, because I have to choose 2 columns. Okay, and then when I have found out all those numbers that has 2-bit set, I will now, for those particular configuration, check how many rows are covered. Okay, and then we just maximize it. That's the overall thing. So let's move on to the code part, something much complicated here as well. So what we've done is that we have one left shift, like left shift m times, that is number of columns, so that will I will get that particular 2 to the power of that number, and then I'll iterate over all that number. then I have to find out how many particular numbers, like how many particular bits are set, okay, in that particular number that I have, because I have to like match that number of bits that are set in the particular number should be equal to columns. Okay, so I've taken this visited matrix. You can just find out using bit set function C++ also. Like there are multiple options to check that. Now iterate over all the m positions in that particular number. If that particular bit is set, okay, then just mark it as 1 and count as plus plus, that I have like incremented the count. If the count is not equal to calls, that number of bits set in a particular number is not equal to number of columns I want, so just continue, because I actually want a fixed number of columns to be set, okay, for the particular configuration. If it is set, I have particular column, that I just find out how many rows that are set. So just iterate over all the rows and just check that if a particular row is like what you can say, a particular row is applicable for a particular configuration or not. So for that I have to just check that for at least any one of those columns that I have, it should be equal to 1. Okay, so any one of should be equal to 1, that we have checked here. If it is, we increment the temp and we just maximize the temp for a like number of rows for a particular configuration and just print out the answer. So it's pretty much simple. You can code it out. I will link all the codes in the description of this particular video. This is actually all the 3 codes for this problem set. Thank you for watching the video till the end. If you still have any doubts, you can mention down in the comment box. I will see you in the next one. Till like, keep coding and bye.